This is a typical representation of a hydrogen 2pz orbital. We know this is an n=2 orbital because there is only a single node present. We know this is a p orbital because it has a single planar node. And we know this is the pz because the nodal plane does not contain the z-axis. The representation of a p orbital by two lobes is fairly common, with the different colors indicating different phases in the underlying wave function. However, it is important to always remember that these lobes are not sharp boundaries for the orbital. Instead, they show the volume in which we have some likelihood of finding the electron when we go looking for it. In this case, the lobes are drawn large enough that we should find an electron in the volume roughly 90% of the time we look for it. But the electron in this orbital can be found anywhere that is not a node, even beyond the lobes we have drawn. Indeed, we expect fully 10% of our searches to provide an electron position outside of the lobes. We can try to visualize this by simulating the results of finding an electron multiple times. If we look, we might find it here. Next time we look, we might find it here, and so on. We can continue to keep looking over and over and over. In this simulation, we will look 1,000 times. The bright flashes are indicating where our most recent observation found an electron, while the duller spheres are places where we have already found an electron. You can see that we are finding most of the electrons in two areas above and below the xy plane. This is just what we expect. Indeed, we find that we have a shape that looks strikingly like the lobes we started with. You can see that the majority of the instances in which we found an electron are contained within the lobes, though there are a reasonable number of electrons found outside the lobes. And so, what these lobes are trying to represent is a boundary on where we are likely to find an electron, rather than the definitive edge of our 2pz orbital.